Good afternoon, everybody. I hope you can hear me okay. I'd like to just give you an update on some research we're doing at Uconn in the plant science department. I'm an entomologist and I'm part of the IPM program, but I mostly do some teaching and research. And we have been working for a while now with some cultural management options for pests in brassicas. Particularly, we have been doing work with cabbage as kind of a model crop, but we hope that what we learn on cabbage, we can translate to other crops. And one of the things that I'd like to talk a little bit about today is the use of trap crops. I have also worked with insectary plants, which is the use of plants to attract beneficial insects, but that would be for another time where I can tell you. Thank you. Yeah, let's see. Yeah. So our interest in trap crops comes because this is a very important IPM cultural option. There have been many systems in the Northeast that have been tested, primarily work with the striped cucumber beetle using hover squash as a perimeter trap crop. Some of you might have heard about that work that was done here in Connecticut, and also in Massachusetts, they have done that work. There's also been some research on perimeter trap crops for the pepper maggot, which is a very important pest. So there's been work on many systems, and we wanted to try the idea for brassica pest management. That has also been done in other locations, and essentially what we hope to do is implement a system where you have here a trap crop is a plant that's very attractive to the pest. And as the pest insect comes from the surrounding habitat, it's going to be intercepted and concentrated on the trap crop. So you have your cash crop here, and our goal is to try to intercept the pests so they are not all over the place, but just concentrated on a smaller area. The benefit of doing that is that if you apply a pesticide or you do some other type of management tactic, you reduce the area where you have to employ that tactic. So trap crops have many benefits. There are many ways you can implement the use of a trap crop. Primarily, we hope to reduce the pest pressure on the cash crop. We also hope to reduce insecticide use by, again, concentrating the pest on a smaller area. The other aspect too is that we want to reduce the risk to natural enemies, and we achieve that by, for example, if you concentrate the pest in a smaller area and you have to use a pesticide or destroy that type of planting, you only afflicting a smaller area, and the natural enemies, those beneficial insects, can be on the cash crops, helping you with other pests that could be around. Another very important aspect of trap crops is that it's another tactic. It increases the diversity of tactics we have available for pest management. And the more diversity we have in tactics, the better, because we have many problems, for example, with pesticide resistance. And one of the pests that we work with, the diamondback moth, is one that is very likely to develop resistance to many insecticides, conventional or organic. So we want to have many tools so that we can vary our approach. So we had some inspiration from other researchers. For example, in Florida, they have done work with trap crops for the diamondback moth in large commercial fields. And we, have taken sort of that background plus other work from others to try to develop a system for the diamondback moth. It's a small moth. You probably have seen it. The caterpillar is very small. They kind of wiggle if you disturb them off the plant. And in spite of their small size, they can be quite detrimental. And again, the challenge with this insect is that it's very likely to develop resistance. So that's a concern that we have. And that's why we want to have different options for its management. It has been documented to develop resistance against BT, which is a common tool organic and conventional growers are used, against spinosal, making different types of materials. Now, in the research I'd like to tell you a little bit about today, we've been doing this for a couple of years. There's still more to do in terms of understanding some aspects, but hopefully it'll be of some interest what we have found so far. We want to implement the trap crop using what we call a push and pull system. And this is done by having your cash crop there, and you plant a trap crop around the edge. That would be like your typical perimeter trap crop. And we add another factor to this to make it better, and that's adding a repellent plant, a plant that is kind of going to push the pest away from the cash crop, and then you have the trap crop on the edge pulling it in. So that's the push and pull part of it. And in this case, for this system, we have a number of trap crops that we tested, and we also have, and here we only did tomatoes as our repellent plant for this work. So this is what we used for the repellent crop. We had a tomato, mountain merit, and for the trap crop, we tested 4 different ones: glossy collards, red Russian kale, upland cress, and garden cress. We selected these plants based on previous research that had shown there could be some likelihood of success, but we wanted to know better if they would work in our area. And this was part of a, sorry, skipped it, a photo there, yeah. This was part of a master's thesis work by Mausia Rugnategui, who's a graduate student in our department. And she managed these plots. You can see there, this is at the Plant Science Research Farm, and where we have the different experimental plots with various combinations that I just mentioned. And we did this for 2 years. And so we have results in terms of summer of 21 and 22. What you're seeing there is just the pattern of the pest population on the different type of arrangements. The thing to note here is the orange line is the one that has nothing to it, just the cabbage alone. And that had the highest number throughout the season. The lowest numbers came with kale and the collards. So those two push and pull systems were the best in that year, overall having the lowest pest pressure. The upland cress and garden cress didn't do so great. In summary, you could probably see it better there, where again the collards, this is for the same year, summer 21, the collards and with tomato together as a system, and the red Russian kale and tomato work the best in reducing the diamondback moth on the cabbages. So again, this is this summer was one where we faced tons of rain. If you remember, our fields, some of them, we actually lost some areas because they were inundated, but we survived it, and we managed to do that. I mentioned this because the next season was quite the opposite, but we still saw some interesting patterns for 22. We see again, the orange is the one that has just the cabbages by themselves, and the best ones there, again, the kale with the collards in combination with tomato were the better ones overall. You can see that again in different formats, the same thing, but just different thing, arrangement. Collards and Russian kale were the better ones. That this year in 22, we did try cabbage and tomato alone, just that combination, and that did reduce the pest numbers on cabbage too. Although statistically not significant, but it's an interesting pattern. We hope to repeat that to see if in another year we see the same result. So from this summer was quite dry, which like we hardly had any rain at the research farm, so we had to irrigate a lot, but it was a very different environment. But in both years, either the very wet or the very dry, we still saw the same pattern in terms of the reduction as a result of the systems we were trying. So in conclusion, we see that the kale and tomato combination and the collard and tomato combination has potential. So we're gonna keep exploring those. Keep in mind, this is a small plot, so our goal is in future research to really expand it to larger areas, test different densities of plantings, different arrangements. For this year, we only used the perimeter trap crop arrangement surrounding the fields with the trap crops, but we want to try it out in different formats to make it more practical. The next goal will be just to try rows that we could plant with the trap plants and obviously the push plants. So just not to have this kind of a square arrangement as I've shown you, but there's more to do. And you know, I think that this hopefully will provide a couple other options for in terms of management of this moth. There are other insects as well. You're probably wondering what happens to the other insects. That's another challenge we have to address, but I think the idea here is that the diamondback moth can be very susceptible to resistance. So we want to have already some other options for that reason. Thank you, and I'll be happy to take any questions.